Many students are often surprised to find that a production process can have diminishing marginal product in all of its inputs and still have increasing returns to scale. It's actually pretty easy to demonstrate this possibility mathematically, and it's a little harder to see it intuitively. We'll try to do both here. We'll begin by holding labor fixed at the amount LA and illustrate the vertical slice of the production function that's Cobb-Douglas with exponents 2/3 and 2/3. We know that the horizontal slices of a Cobb-Douglas production function give rise to isoquants that have the usual shapes. We can then use several of these isoquants to indicate what the general shape of the overall production function is like, and note that the slice that we've taken out at labor level LA has a concave shape. That is to say, we can take any 2 points on that slice, and the line that connects them lies fully below the production frontier. This vertical slice is then a single input production function that varies capital while holding labor fixed. Its concave shape tells us that the slice starts out relatively steep and becomes shallower and shallower. Thus, since the slope of a single input production function is the marginal product of the input that's being varied, we know that the marginal product of capital is falling along this single input production function. We can show this mathematically by taking the partial derivative of the marginal product of capital with respect to capital. In that equation, the only term that can be negative is the beta minus 1 term, and that term will be negative so long as beta is less than 1. In the production function we've specified here, beta, the exponent on k, is 2/3, and therefore beta minus 1 is negative, implying that the partial derivative of marginal product of capital with respect to capital is negative. In other words, marginal product of capital is diminishing. The same holds for marginal product of labor. As you can see in the other equation, the partial derivative of marginal product of labor with respect to labor has the term alpha minus 1 in it, and therefore is negative so long as alpha is less than 1. In our case, alpha is equal to 2/3. Therefore, the derivative of the marginal product of labor with respect to labor is negative, implying diminishing marginal product of labor on any slice that holds capital fixed. In panel B, we repeat the exercise, but this time use the Cobb-Douglas production function L to the 4/3 times k to the 4/3. In other words, the square of the production function that was used in panel A. We know from our work with utility functions that squaring a utility function doesn't change the shapes of the indifference curves within the indifference map. Therefore, the shapes of the isoquants here will also not change. The single input production function that's formed by holding labor fixed at LA now clearly no longer has a concave shape. Take any 2 points on that slice, and the line that connects them lies fully outside the producer choice set. This implies that we now have increasing marginal product of capital. You can also see this in the equation, because now the beta term is above 1, which means the derivative of marginal product of capital with respect to capital is now positive, implying it is increasing. The same holds for marginal product of labor, because alpha is now above 1. We can see whether these functions have increasing returns to scale by looking at the shape of the vertical slice along a ray from the origin, like the 45-degree line. When we plot out the shapes of these slices, we see that in both cases the slopes are increasing at an increasing rate. In other words, both production functions have increasing returns to scale. This will be true for Cobb-Douglas functions so long as the exponents on the two inputs sum to greater than 1, which they do in both cases. Panel A therefore illustrates a production process that has diminishing marginal product of all of its inputs, but still has increasing returns to scale, while Panel B illustrates a production process that has increasing marginal product of all of its inputs and increasing returns to scale. You can see these possibilities easily emerge from the Cobb-Douglas production function. Such a function will have increasing returns to scale so long as the exponents on the inputs sum to something greater than 1. This is the case in both of our production functions. Diminishing marginal product of an input, on the other hand, requires that the exponent on that input is less than 1. This is true for the two inputs in panel A, but not in panel B. Since it's possible for the exponents to both lie below 1, but to sum to something greater than 1, it is therefore logically possible for the production function to have increasing returns to scale while having diminishing marginal product in all of its inputs. If one of the marginal products is increasing, on the other hand, it means that one of the exponents is above 1, which then implies that the sum of the exponents is above 1, and therefore the whole production function has increasing returns to scale.